Welcome to my first YouTube video. This video will be about the automatic plant care. The main feature of this robot is the Raspberry Pi Vex IQ communicator, which can be seen on the right. The purpose of this channel is to demonstrate robots that accomplish useful tasks. Here are some robots that are in the pipeline. Subscribe if you wish to see them in action. The plant care robot came about when I attempted to plant seeds, with miserable results. Either a lack of water, too much or too little sun, did the little guys in. So the plant care was invented. Here's a video of it in action. There is a hardware and programming component to the robot. I will go through the software in detail as an addendum if anyone wants those details. The hardware consists of a Vex IQ structure with motors that move the watering mechanism, a Raspberry Pi, the aforementioned Raspberry Pi Vex IQ communicator, a Vex microcontroller, a relay, a watering pump, a water container, a grow light, and an automatic timer. Now let's go through how it works. The Raspberry Pi has a real-time clock that, when triggered, turns on an LED light. The light is sensed by the Vex IQ microcontroller, which runs a program to position the irrigation hose over a plant. When positioned over the plant, the microcontroller activates a motor on the Raspberry Pi Vex IQ communicator. This motor pushes a button that is sensed by the Raspberry Pi. The Raspberry Pi turns on a relay attached to a water pump. The microcontroller will then move to the next plant, and once again signal a water pump via the Raspberry Pi. My solution for the lighting was just using an automatic timer. If one wanted, the lighting could be routed through the Raspberry Pi also. Once the seedlings were large enough, they were moved outside. Here's a time-lapse of me planting the plant care graduates. Thank you for listening until the end. I really hope you enjoyed my presentation on the plant care, featuring the Raspberry Pi Vex IQ communicator. While you're still here, I'd like to clarify a few things. Firstly, it did not always work. And secondly, there are many ways this project can be improved upon. And one of my wishes for this video is that it inspires new and better ideas. I plan on posting more of my engineering projects, so if that interests you, go ahead and subscribe so you don't miss them. See you next time. Here is the addendum where I describe the code. Let's start with the Robot C code for the Vex IQ microcontroller. The first section explains to the microcontroller where the sensors and motors are. The Robot tab is used to fill in where the motors and sensors are plugged in. Next, we can see my explanatory comments on the code. This program is organized by creating a series of functions that would be called in task main to move the irrigation hose over all the different plants. The trigger water function will tell the Raspberry Pi to turn on the pump. The function will cause the motor on the Raspberry Pi Vex IQ communicator to push the button on the breadboard. Recalibrate is the next function, and it will actuate the motor so that the entire watering apparatus moves to the left and backwards until two buttons are pressed. This ensures the same starting point. First pop moves the irrigation hose over the first plant from the recalibration point. The move away function and the next 5 functions define smaller movements that, when put together, take advantage of the repetitive nature of the watering to allow for a more condensed code. Next, we see the task main line. Task main is where the Vex IQ microcontroller will first look to start executing code. The next line declares the variable water time as an integer equaling 2000. This means that the irrigation hose will stop for 2 seconds to water each plant. The while true loop will allow the Vex IQ code to continuously be ready for a signal from the Raspberry Pi to start watering the plants. Further down, there's an if statement. If the Vex IQ microcontroller notices that the light sensor monitoring the Raspberry Pi is greater than 5, then it will execute the subsequent code, which waters 24 of the plants. Lastly, there is the Python code running on the Raspberry Pi. The Python code starts with 3 imports. These tell the Raspberry Pi the layout of the input-output ports, how to handle time, and how to interpret dates. Next, the code explains where the different inputs and outputs are located on the general-purpose input-output pins. The function called on-off Pi light will turn on the LED connected to the Raspberry Pi. This, in turn, will be picked up by the light sensor connected to the Vex IQ microcontroller, triggering the movement of the watering mechanism. The while true loop will continuously be monitoring the time. The last if statement will trigger the Raspberry Pi to turn on the watering pump via the relay. Thanks again for listening.